Hello class, in this video we are going to look at some of the application questions where students find it difficult to solve in the graphical aspect of quadratic equations. So still under the graph of quadratic functions, these questions were given to students to solve, and 90% of the class were not able to come out with the required solutions. So from the question, it says we are to prepare a table for the relation y equals 2x squared minus 3 in the interval negative 3 less than or equal to x less than or equal to 3. And then the second part, we are to come out with a graph for the relation in the same interval. The next part, we are to use the graph to find the truth sets of x squared minus 1 equals 0, value of x equals root 5, the minimum point, and the axis of symmetry. Let's delve right into this.
Welcome to Math with Father. Welcome to Math with Father. Subscribe, like and share.
So the first one, we are going to prepare a table for the relation y equals 2x squared minus 3 in this interval. So in preparing a table for our equation y equals 2x squared minus 3, we are going to come out with the values of x which was given. So the values of x given was with the interval. So these are the values of x: negative 3 less than or equal to x less than or equal to 3. So with the table, we have x ranging from negative 3, negative 2, and the second column, the second row takes the y coordinates. Okay, so we are going to find the values of y by putting in these values of x in the equation. So from the chief examiner's report, always solve at most 3 solutions here. So the solutions for y should be visible here. So at most 3 is okay. Now let's see when x equals negative 3, y would be, so y would be equal to negative 3 squared, that would be 9 minus 3. So y equals 15. Now 15 is written nicely over here. When x is negative 2, what do we get for y? Okay, so after doing 2 or 3, you can move on by substituting the other values of x inside, and then you complete the table. So after substituting the other values inside, these were the y values that I had negative 1, negative 3, negative 1, 5, and 15. So these are the coordinates of y with its respective x coordinate. So we are done with the first part, which says we should prepare a table for the relation in this interval. Now we move on to draw our graph. We move on to represent these coordinates on a graph, which helps us to come out with the curve. So looking at the nature of our function, we could now discern that the nature of our quadratic function will be u-shaped, because the coefficient of x squared, which is a, is 2. So this will be the shape of our quadratic function. Now let's move on to the graphical part of it, which is the drawing or the diagrammatic part of this equation. But before that, from the question, we were not given any scale. We were not given any scale to represent the x and then the y values. So the scale is taken from the values or the range of the x and the range of the y value. So from this, so x ranges from negative 3 to positive 3. So the smaller here, negative 3, and then the upper here, positive 3. So this is the range of values of x, negative 3, positive 3. Now let's move on to the range of y. So the smaller value for y is negative 3, and then the bigger value or the biggest value for y is 15. So let's write them here, negative 3, 15. So from the graph, the boxes or the vertical boxes are 12. The vertical boxes are 12, and then the horizontal boxes are 10, which is the standard graph sheet. So with the x axis, we would choose a scale of 2 centimeters to a unit, 2 centimeters to a unit on the x axis. So on x axis, and then on the y axis, since it's also 12, the scale should also be 2 centimeters to 2 units on y-axis. Okay, so these are the skills that we are going to use in plotting our values of x and then y. Let's delve right into the graphical aspect. Okay, so with the graphical aspect, we are going to use this resource tool to come out with our graph of the function. Now with the question, we've chosen our scale. We move on to plotting the coordinates, the minimum value of x, which was negative 3 from the table. The smaller value of x, negative 3 here. The bigger value for x was 3. The smaller value, the minimum value of x was of y was 3 negative, and the maximum, the biggest value of y was 15. All right, so this is our graph, the portion for, or the space for the graph. Now the minimum and then the maximum of x and then the y has now been set. Let's move on to plot the points. For the first point, we have negative 3 for x, 15 for y. So I'm labeling that point A. So point A. Okay. Okay. So after locating the point, I didn't get the exact figure, so I'm now going to insert in the exact figures. Negative 3 here, 15 for y. Negative 3, 15. So this is it. This is the point for the first x and then y coordinate. We move on to the second point, 2 5. 2 5. Negative 2 5. So I've also named that point B. Negative 2 5, which is placed nicely over here. The next point is negative 1. So the point is also labeled C. Negative 1 is also done nicely over here. Now the next point is 0 negative 3. Okay, so that point is also labeled as D. 0 negative 3. Also labeled nicely over here, 0 negative 3. Let's move on to the next point. The next point is also labeled as E, which is 1 negative 1, also located nicely over here. Let's move on to the next point. The next point is also labeled as F, point F 2 5, and it's also located nicely over here. The next point is also labeled as G 3 15, also located nicely over here. So we were to draw the graph of this function using these points, and this was the equation for the function. The equation for the function y equals 2x squared minus 3. So we could now see that the curve passes through the point. The curve is passing through the point. This becomes the graph of the function y equals 2x squared minus 3 equals 0. So this is the graph to the function. Let's move on by finding the sub questions. So we are done with the table. We are also done graphing the relation. Now we move on to find the subsequent questions. So what we see here are the features of the graph, are the things that we are going to notice on the graph. So I will start with the first one, which is the minimum point.
Subscribe, like and share.
Okay, so from our diagram or from the parabolic shape, we could see that the graph started here, and then at point D it turned. So the values of y were decreasing, and then at the point D it turned. So this is the turning point of the graph, and that point is the minimum, which is the least. And what are the values there? The values there are 0, 4x, and then negative 3, 4y. So this point becomes the minimum point to our relation. So from the graph, our minimum point is 0, negative 3. Now we move on to the next part of the question, which is the axis of symmetry. The axis of symmetry.
Subscribe, like and share.
For the axis of symmetry is the line that divides the curve vertically into two equal parts. So looking at our curve, the line that divides it vertically into two equal parts. So you see the curve turns at this point. So let me come out with a different line. The line that divides it vertically into two is the red line. Is the red line, and it's a vertical line, right? Passing through 0. Passing through 0. So that line should intersect the x-axis. That line should intersect the x-axis, and so it's intersecting the x-axis at this point, x equals 0, and that line becomes the line of symmetry, which divides the parabolic shape or the relation or the graph into two equal parts. So our line of symmetry is x equals 0, which is the red line dividing the graph or the curve into two equal halves. So our line of symmetry would be 0. X equals 0. So this is our line of symmetry. Now we move on to the next part, which is the truth set. The truth set of x squared minus 1 equals 0. Truth set of x squared minus 1 equals 0. So initially, if you were asked to solve for this, you would go straight forward by using the factorization method to find the root of x. So kindly do this by using the factorization method to solve in less than 30 seconds. So I know 90% of the class was able to find the root of this equation using the factorization method. But here we are going to use the graph to find the root of this equation, and the relation given was y equals 2x squared minus 3, and the equation given is going to be compared. So the equation given here is going to be compared to the relation which was y equals 2x squared minus 3. So by comparing we are to make sure that the coefficient of x squared of our relation, which is 2, also appears. So we are to make sure that the equation given has the same coefficient of x squared. Now the coefficient of the equation given is 1, and the coefficient of the relation of x squared is also 2. So we are to manipulate this to also bear the same coefficient of x squared. Now what do we do to make the given equation also bear the same coefficient of x squared? What we are to do is to multiply the equation given by 2. So multiplying it by 2. So multiplying 2 by this equation, this is what we are getting. Two x squared minus 2 equals 0. So with our result, we are going to compare this to the relation given. Now we have y equals 2x squared minus 3 minus, so we are comparing it with this, 0 equals 2x squared minus 2. Now let's compare y minus 0, which is y, 2x squared minus 2x squared, which is 0, minus 3 minus 2, which is minus 1. So this is what we are getting for y equals minus 1, and y equals minus 1 should be plotted on the graph. So on the graph we are going to plot y equals minus 1. Y equals minus 1 is this blue line. So you could see the line is intersecting the curve at this point, and then at the same time at this point. So the values of x is the intersection between the point and then the curve, and they are meeting at -1 on the x-axis and then 1 on the x-axis. So from our graph, which is x squared minus 1 equals 0, gives us these values of x. X is such that x is equal to -1 or 1. X is such that x is equal to -1 or 1, and this is done nicely over here. So let me plot in the equation x squared, and let's look at something here. X squared. So after putting in this quadratic equation, we could see that there are these two lines. Let me change the color. There are these two lines. So these two lines are intersecting the x-axis at -1 and 1, and we could see that these two lines are passing through the meeting point of y equals -1 and then the curve. So these values are the x values, which is -1 and then 1, and the graph has been used to prove the roots of this equation. Now let's move on to the second aspect. So for the second aspect, we were to find the value of x equals root 5. Find the value of x equals root 5. X equals root 5. Now, every equation which is seen in the question is compared to the relation. So we are also going to compare this to the relation y equals x squared, 2x squared minus 3. And what we are placing emphasis on is the coefficient of x squared. But before that, the equation given here was x. So this is a linear equation and this is a quadratic equation. So this has to be transmuted to a quadratic equation before we convert it, or before we find the coefficient of x squared. So from here we are going to square both sides. So by squaring both sides, we have x squared equals square root of 5 squared, and this gives us x squared equals 5. The same equation could be written this way: x squared minus 5 equals 0. So we now have a quadratic equation and should be compared to this. But before that, the coefficient of x squared should also be the same. The coefficient of x squared here is 1. The one with the relation, or the given relation, is 2. So we have to manipulate this to also bear the same coefficient. Now we multiply it through by 2. So multiplying through by 2, we have 2x squared minus 10 equals 0. Now we compare to our given relation. So y equals and then 2x squared minus 10 equals 0. 0 equals 2x squared minus 10. So by comparing, y minus 0, which is y, equals 2x squared minus 2x squared, which is 0, negative 3 minus 10, which is 7, so positive 7. Now y is equal to 7, and we are going to plot this on the graph. So from the graph, we plot y equals 7. So y equals 7 is somewhere here. Let me change it. Y equals 7 is this green colored line, and the green colored line is intersecting our curve at this point. So let me locate that point. It's intersecting here, and at the same time intersecting here. So on the first x coordinate, we could see the point to be negative 2.24. So negative 2.3, negative 2.2. And then the second coordinate, we could see 2.24, so which is 2.2. So these are the x values. These are the x values Now let's put in the equation to see where the line intersects the x-axis. So the equation was x squared minus 10, 2x squared, or x squared. So these are the points. So these are the points. So you could see that this yellow line passes. You could see that this yellow line passes through this point, which is negative 2.2 and then positive 2.2. So intersecting the x-axis at this point, at the same time this point. Thank you for watching this video. So if it was very helpful, kindly subscribe, like the video, and give me a thumbs up. So subscribe to the channel. Anytime I post a new video,
Subscribe, like and
put
share.
me on post notification. Now the last aspect of the question. So from our graph, x is equal to root 5, and these are the roots. X is such that x is equal to negative 2.2 or positive 2.2. So these are the solution sets. These are the solution sets to our question. To our question. So we were able to come out with the table. So which is this? So this was the table. We were able to come out with our table, which is this. We were able to come out with our graph, which is also this, the graph of our relation, which is also this. And we were able to find the features, which was finding the root of x squared minus 1 equals 0, which is this blue line, and the coordinate of the x were these light blue lines. We were also asked to come out with the coordinates, or to find the roots of the equation x equals root 5, which was the green line, after comparing the equation to the given relation, and this yellow lines intersect the line and then the curve at this point, connecting to the x-axis. So if this video was very helpful, kindly like my video, subscribe to the channel, and put me on post notification anytime I post new video. And let's build together as a family by making math and science a reality. Thank you. I'm out.